Hello, today we're going to talk about neutralization reactions and start titration. Then, yeah, we'll do titration for 2 days, and then you'll have like a virtual lab, and that's it for the unit. So next week we'll end up having a test, open note test, I guess. Okay, all right, so please open up to page 8. And this is neutralization reaction. I'm going to make this bigger in a minute, but I want to flip to your reference table for a sec. Okay, so we have an acid plus a base, and an acid and a base neutralize each other. An acid and base neutralize each other to make a salt plus water. So salts are neutral when they come from a strong acid and strong base, and then water is also neutral. So the salt is just an ionic compound. Remember, so it's made of a metal and a non-metal. Okay, so before we start doing these problems, I want to remind you that you can find a lot of these symbols on your reference table. Okay, so your reference table is right here, table K and table L. So I'm going to do a couple of these with you, and then you're going to just push pause and do the rest on your own. So let's start with number 2, and we're going to do nitric acid plus magnesium hydroxide. So nitric acid is on here, it's HNO3. Magnesium hydroxide is not. So I'm going to show you what you have to do in that case. Okay, so we have salt plus water. Okay, so I'm going to do the symbols first. So nitric acid is I'm doing number 2. HNO3. Well, I can do that for the first one because it's the same. Okay, plus magnesium hydroxide. So before I just go down and write MgOH, I need to look up the charges and crisscross them. So Mg is in group 2, so it has a +2 charge. Hydroxide is a table E problem, or polyatomic. So when you crisscross them, you get MgOH2. All right, so what I would recommend is always doing water first, because water is always going to be part of your answer. And now you're going to get the salt. So I want you to just take a peek here. Do you see where water came from? So we have OH and H. So when they combine, you get HOH, which is the same as H2O. These are also double replacement reactions, so the outsides combine and the insides combine. So this is the part that's kind of a pain. When you combine to make the salt, you do have to look up the charges and cross them. So magnesium is +2, nitrate is -1, crisscross, I get MgNO3 too, which is named magnesium nitrate. So you're just about done. Now you need to go back and check, does it need a balance? So I can tell right away it is, because NO3 right here, there's 2 of them. So I'm going to put a 2 in front. Now I'm going to add up my H's. So I have 2 H's here. And then I have OH in parentheses 2. So I have 2 H's for a total of 4 H's and 2 O's. So we need a 2 here. Okay, so that's number 2. I'm going to do number 5 also. Okay, so number 5 has hydrochloric acid plus lithium hydroxide. All right, so I'm gonna go into my reference table. Hydrochloric acid is right here, HCl, and lithium hydroxide is not. So that means I'm gonna have to figure it out myself. Okay, so we have HCl plus lithium hydroxide. So lithium is group 1, so it's +1. Hydroxide is OH -1, so you get LiOH. You always make water, so just pop H2O in there. Don't even worry about how many things you have on the left-hand side. Water, and now I'm going to combine to get the rest. So I'm going to combine lithium and chlorine. How come I'm putting lithium first? What do you know about the charges? So the positive ion has to come first, so that's why I'm writing it first. So Li is +1, Cl is -1, so it's just LiCl. And that is lithium chloride. Okay, so you're gonna go back through and just check to see if it's balanced. You have 1 Li, 1 Li, 1 Cl, 1 Cl, 2 H's, 1, 2, and 1 O, so we're good. Okay, so at this point, please push pause and try to complete the rest of the problems using the ones we just did as an example. Remember, a lot of these are in your periodic tables, okay? So push pause, try those. And then I'll put the answers on the board. Okay, so here are the answers. So nitric acid, you saw was already in your reference table, and so is sodium hydroxide. So H2O comes from these guys, and then you combine Na and NO3, and Na is +1 and NO3 is -1, so you get NaNO3. It does not need a balance. We did 2 together. So let's do 3. Sulfuric acid comes from your table. Magnesium hydroxide we did in question 2. So first thing I would do is always write water. And I would ignore these numbers until I balance. And then I'm going to combine Mg and SO4. And since it's +2 -2, they cancel out and you get MgSO4. And then I put a 2 here so that it would balance out 4 H's and 2 O's. All right. I think I've got the switching the mouse thing down. We'll see. Okay, 4. Sulfuric acid is in your reference table. So is potassium hydroxide. So water comes from these two. So whatever's left is K and SO4. So K is +1, SO4 is -2, cross, I get K2SO4. So since I have 2 Ks, I know a 2 needs to go in front, and then I would have 2 O's and 2 H's, 2 O, 2 H's, I have 2 H's over here, so 4 H's, 2 O's, I need a 2 there. All right, we did 5 together. So 6 sulfuric acid in your reference table. I don't think barium hydroxide is. So barium is +2, hydroxide is -1, crisscross, BaOH2, yield water. And then you have barium left over and sulfate left over, which gives you BaSO4. 1 Ba, 1 Ba, 1 SO4, 1 SO4. I have 2 H's here plus 2 H's here, 4 H's, 2 O's, so I need a 2 and right there. Okay. Look at me, I was bragging about being able to do this and then I couldn't do it. Okay. Oh, I think for some reason the last problem for you guys is not on there. So it says which equation represents a neutralization reaction? So you need an acid plus a base makes salt and water. So you'll notice that the only thing that has 2 products and includes water is choice C. Okay, so we're gonna do this page only, and then with the graph, and then we'll wrap this up tomorrow. Okay, so titration. This is a big lab we would have been doing in class. It's actually kind of fun, but takes a lot of patience and some skill. So an experimental method to determine the known concentration of an acid or base of an unknown concentration using a known concentration or standard of acid and base. So in words, what's happening? You are adding a known concentration of base. I'm just going to say this because this is what we would have been doing in the lab, to an unknown concentration of acid until it is neutralized. And when it's neutralized, moles, that's an arrow, kinda. Moles of acid equal moles of base. So moles of H plus equal moles of OH minus. This point is called the equivalence point because that's where things are equal. Basically, when you do this reaction, so I'm saying that we would have base up here in the burette. Down here you would have an acid that you don't know plus phenolphthalein. So remember that when you have an acid with phenolphthalein, it's colorless. So basically what I would do in the lab is I would just add base until it becomes neutral. And the way I'm going to know it's neutral is you're going to see a color change. So you're going to have a color change. Remember that a triangle means change when done. And this is called the end point. So not the equivalence point, this is called the end point. Okay, so pause this video and I want you guys to graph the graph below, and I'm going to pause the video and do the same thing. Okay, so I graphed mine, you should graph yours. Okay, so basically what this graph is showing you is that when you start, you're starting with an acid, okay? So when you have an acid, your H plus is greater than your OH minus. So you have extra acid. I'm going to add base to my acid slowly, and then what you'll notice is that if you're measuring pH along with volume, you're going to get this huge jump. So it's going to be from here to here, and actually one drop is what's going to do this huge jump. So the midpoint of this section is going to be where you're neutral. So at this point, this is the equivalence point. And this is where moles of H plus equal moles of OH minus. I don't know if you can hear my kids screaming. They're playing with my husband. Okay, and then above that point, now when you're adding more stuff, then you're going to have extra base. And it would be super pink because we have phenolphthalein. So you had H plus is less than OH minus at this point. Okay, so tomorrow I'm going to teach you guys how to do the equation. It's very easy. And then we'll wrap this unit right up. All right, I'll talk to you later. Bye.